Due to new information given to me by FECore President Mike Cavanaugh, so let's talk about the unsupported claims, missing evidence, terrible methodology that FECore did or claimed to do. First, here are a few definitions. Beam divergence. Beam divergence is an angular measure of the increase in a beam width over distance from the optical aperture from which the beam emerges. This measurement is typically in milliradians, or mrad, or degrees. Beam collimator. A collimator is a device that filters or aligns a stream of rays so that only those traveling parallel to the specific direction are allowed through. Collimation of light can be achieved either by a lens or a physical barrier. The sole intention of this is to reduce beam divergence. Let's talk about the types of laser tests. So, there are three basic styles of laser tests. There's the point-to-point test, which is shooting a leveled beam across an area from a measured height, illuminating a target at the distant end, and then comparing those heights. A step test, which is shooting a beam across an area, and then making interval beam height measurements across that area. And then there's the I see it test, which is observing a laser's source glow from a distant location. FECore President Mike Cavanaugh stated to me that the purpose of the FECore laser test was to hit a target with a laser, and from that, determine if the surface between both the source and the target was flat. In order to make this point-to-point determination, the laser at the source must be leveled. This point was even illustrated 10 times in their results document. Otherwise, you have no idea what your results are telling you. Leveling the laser was claimed by FECore to have been accomplished in any of 4 different ways. A laser level, a digital angle indicator, a height measurement of the beam on the distant target, and simply pointing the laser at the horizon. Let's examine those. The laser level, while shown in the results document, was never shown what readings it took when compared to the beam being projected at the same time, and due to its freedom of movement, was not a useful choice. The only digital angle indicator, which was shown or even acknowledged, was in steps of the stepper motor driving it. So that is not of real use. And if one was used and just left out of the results documentation, then depending on the accuracy, no other measurements would have been necessary. The height measurement method on the distant target, which was outlined by Mike Cavanaugh in my live discussion with him, would have helped a lot. Mike claims to have gotten measurements on it all the way down to the micrometer, yet in the results document nobody mentions it or shot a photo of this process. Which leaves the leveling method, which was described on page 13 of the results, which said they just pointed the laser at the distant shore. Leveling the laser was such a priority to the FECore crew that of the 20 times the word level was used in the results document, not one of them had anything to do with leveling the laser. Despite having a long comment section discussion about how well he claimed FECore did level the laser, later, Mike Cavanaugh stated that leveling the laser at its source was not important.
Okay? No, that's what you are trying to put words in my mouth.
I'm not putting words in your mouth. Did you not say that leveling the laser at the emitter is irrelevant because you are doing your measurement at the reference or at the target?
No, I
just said that.
Leveling your laser at the source location is irrelevant because the leveling is done at the reference location, and then the level is confirmed by the level transit on the horizontal axis.
Okay, so his only goal was to hit a target on the other side. But what was the ultimate goal of the test? Was it to see the laser at the other end, or was it to hit a target?
To hit a target.
And did you hit a target?
Yes.
At 22 kilometers?
At 20 and 27, if I remember correctly, it's 27 or 29.
Now,
the 20 was the reference location. That's where we level out the laser, and then we do a level transit on the horizontal axis of the solid to the target location, and that's the distant location that you want to shoot at. And in our case, with the first test,
okay, 20, now
27.
Mike Cavanaugh stated that his methodology was that if he hit a target at the same height off the water as the source laser, this would automatically mean that the lake's surface was flat. Here's a short demonstration of me showing that if the density of air across a curved surface is increased, the light will bend with the curve of that surface. So per Mike's methodology, refraction would conclude this to be level with the laser emitter, when in fact level is actually here. But that's even if he hit a target. Both versions of the results document state that they used a well-collimated beam. FECore claims their high-precision laser has 0.08 mrad collimation, which is extremely good. But this is an interesting specification, because over a year before FECore ever existed, this same laser with functioning collimator was used in a Dr. Zach video, also at Lake Balaton, yet was only able to achieve an approximate 0.4 mrad of collimation, which is 5 times more dispersion than FECore claims in their specs. But of course you can forget all that, because Mike stated to me that they used an uncollimated laser beam, mostly because they broke the collimator, which would have meant many more times laser dispersion, and less accuracy to get those micrometer measurements. According to Mike Cavanaugh, they used an uncollimated laser to get their results over great distances. So let's give Mike the benefit of the doubt and say he has a 1 mrad laser. Well, 1 milliradius of dispersion is 0.05 degrees, which across 20 kilometers results in
20 meters
dispersion. This means that FECore claims to have made quite precise measurements of height off the water with a
20 meters
wavy glob of undefined light, which if the water reflection was as he said, those reflections would also be on the target and been indistinguishable from the direct laser light. So basically it would have all been useless for measuring. Mike stated that they used an uncollimated laser to hit their target. Okay, what was the did you guys measure the dispersion of the laser itself?
No, we used an uncollimated laser for the tests here in the Netherlands, because we're lining up the beam with one ray of the optics. Where there was no real need for a collimated beam, because we're not trying to span a distance of 60 or 70 kilometers.
Really? Because your colleagues seem to be of a different opinion.
So they use the distance between the hotel and the lake to calibrate the collimator lens for the powerful laser they brought. And here is Dave Moore trying to explain how they were doing it.
Just to see if the collimator is working. We're getting a nice coherent beam. Kind of need that, otherwise we'll end up with a beam over 10 miles that spreads out to about a mile wide. So
now, of course, he was exaggerating a bit, but it does show that the folks know the importance of the collimation. But what does collimation have to do with these reflections? His alignment method, at least at Balaton, was completely visual. Mike stated that on the target end, the laser was aligned by using the reflection on the water aligned to their feet. He even says that they made pictures of that.
And we went down to the beach, and the cool thing was that there was no wind, so the lake was a complete mirror, so I could see the reflection of the beam where it was exactly pointing at. So all we had to do was line the reflection up with our feet, and that's what we did. And then we pitched it down vertically so that the camera caught that distinct white flash when you look down the barrel of a laser.
Okay.
We made pictures and video of that, and then we pitched it up again so it was roughly at the same height as the source.
Now, what was the distance of that particular test?
And that was 20.26 kilometers, if I'm correct.
Here is a quick capture of the 2016 test at Balaton. This is during the day. At about 400 meters distance from the laser source, the collimated laser source was still clearly visible at least 1 meter from center beam. So this means that from a 1 meter radius dispersion from the source was still quite visible and would be reflecting quite well off the water. So if viewing the reflection of the source off the water was actually their alignment method, at 20 kilometers, they could be at least off by 100 meters. An uncollimated laser is going to have a source which is visible from a relatively wide angle. The reflection on the water will always point to the laser source when you can see it. Look at this short clip of city lights from across a river. All reflections on the water seem to point at me. So if the laser source is viewable from a wide angle and the reflection on the water always leads to the observer's feet, this is by far not an accurate way to align a laser. Oh, and remember when he said that they have pictures of this alignment process from the target end? As this would be the only place where you would get a water reflection to the feet while looking down the barrel of a laser would occur. That's an interesting point, but we'll come back to that. Not to mention, why would this even be necessary in the Netherlands when they had GPS alignment? Mike Cavanaugh stated that he hit a target with an uncollimated laser at 20 plus kilometers, an event which was required to occur so that the crew can get their leveling results and satisfy the project results which FECore was seeking. But yet, nobody thought this would be an event to capture with a camera. They had a camera at the distant end target location, and they definitely found it important to record the reflections of the laser off the water, but nobody turned around the camera to see the laser hitting the target? This is Mike Cavanaugh explaining why they didn't take any pictures of that. Okay, now, why did you not release photographs of the actual laser at this 20-something kilometer distance? Why did you not release photographs in that results document?
Well, not that there's a perfectly reasonable explanation for that. And the night we went out to get those measurements, when we got those measurements, was actually not intended to actually be an actual measurement. I was just going out there to test if the GPS system was actually targeting the laser in the right direction. So we went out with my phone and a P900, and we managed to get some on camera and some we took some pictures.
Okay.
But unfortunately for that night, because it was a perfect night, we should have brought more massive camera gear, definitely.
But then moments later he said this. Okay, so it's safe to say that although you state that there was a target that was hit, and which would have basically confirmed all of your work, you don't have photographs of it.
No, we do have video and photographs of it, but they're made with a P900, and the P900 is not the best camera that you can have at those locations.
Okay, are these photos and videos, regardless of quality, ever going to be released?
Yes. We're there's a massive dump of media that we're going to release pretty soon. I hope we're waiting for a special occasion.
So which one is it? Do you have photos or do you not have photos, Mike? And why weren't they in your results? The test results document states that FECore used optical visualization with cameras and a measurement board, unquote. They also list a P900, a Canon 5D Mark II, as well as video-capable mobile devices and a GoPro 5 on site. But nobody got pictures of the supposed laser hitting the target. Someone would have to be at the target end of these tests to set up the target and confirm the target hit. Mike states that someone at the target end had a camera and made pictures of the alignment reflection on the water portion of the test. And though I am pretty sure that Mike's comment about the inadequacy of the P900 was meant to be from the laser source location to viewing the target, do you really want to say that the same camera which filmed the water reflection thing was not able to be turned around for a quick selfie showing the laser hitting the target? To those who are listening, if any of this is starting to sound fishy, don't worry. You're not crazy. but what was the ultimate goal of the test? Was it to see the laser at the other end, or was it to hit a target?
To hit a target.
And did you hit a target?
Yes.
At 22 kilometers?
At 20 and 27, if I remember correctly, it's 27 or 29.
Now,
the 20 was the reference location. That's where we level out the laser, and then we do a level transit on the horizontal axis of the solid to the target location, and that's the distant location that you want to shoot at. And in our case, with the first test,
okay,
20,
now
27.
The results document makes absolutely no mention of the claimed horizontal shift test, which they claim was to confirm all of their work. As a matter of fact, the word horizontal is not even used once in the results documentation. The word horizon is used once, but that was only regarding their point-and-shoot method of leveling the laser. Mike stated that a part of this test was to do a horizontal shift of the laser for comparison. This means that what he was doing was testing for horizontal curvature, or left to right curvature. But he never would have gotten this with the locations that he was using, because this comparison would require at least 2 other locations of equal elevation and distance. Those do not exist given the locations used. Not to mention, he would not have been able to make an accurate comparison in the first place, given the humongous wavy blob of light caused by the uncollimated laser.
Stick around, I might teach you a thing or two. It's okay with me as long as it's okay with you.
So, just to summarize, the test results document, which according to FECore is given preferential viewing to paying members, and is even stated to receive critique and refinement by those members before release to the public, was still so bad that the 5/6 tests which were outlined in the document required 14 pages of data to have mathematical corrections, which neither FECore nor the paying supporters weeded out in the first release. So a second release was made, as if the first never existed, and there is no mention of those corrections other than in the file name, which seems to claim that Paul on a Plane offered some edits. FECore did not think that using an uncollimated laser was a problem for making precise measurements across 20 kilometers. However, FECore claims to have made precise measurements with a humongous wavy blob of light caused by the uncollimated laser. FECore found it necessary to make footage of the laser reflecting off the water from the target location, but FECore did not find it necessary to turn the same camera to show the light hitting the target. FECore claimed to want to test the curvature of the horizon in areas where it was not possible to set up those targets. FECore claimed to not have any camera footage of the tests in the Netherlands, but did have a camera on hand to photograph the useless level lines and temperature readings during the tests. So all in all, FECore set out to perform an I see it test while categorically ignoring what phenomena could affect that test, and at the same time produced no footage of anything. Mathematics were so bad that they had to do a second release of their results. Alignment methods were purely visual, and even though Mike claims that there were PhDs associated with this test, it probably would have been better performed by preschool children. To those who donated to these tests, congratulations, this is what your money bought. I guess this is what they mean when they say research flat earth. Y'all have a nice.
Oh my god.